Okay, so again we start by deriving this equation. Once we derive it, we make it equal to 0, and then we factor. And then we find our stationary points. Once we find our stationary points, we can put them on the number line. Test for our intervals of increase and decrease. So in this case, we're gonna get negative and some positive number here. So you know that this is decreasing, decreasing, increasing. You know we have a minimum at x equals to 3. So we can do that calculation now if we want. Also write our intervals of increase and decrease. So next we want to find our inflection points by doing the double derivation. Make it equal to 0. Factor. And get our inflection points. Okay, we're going to put this on a number line. We're going to find y double prime, negative 1, 1. That's concave up. Concave down. Concave up. So we can write our intervals. Once we have our intervals, we can do our sketch. Oh, actually we have to first find our points. So we know what our minimum is, 320, negative 22. We need to still find what our other points are going to be. Okay, so we have a stationary point and an inflection point, and the value, the x value for that is 0. The y value for that will be 5. So remember, this is a stationary point and an inflection point. And then we just have an inflection point at 2, negative 11. So once we have our points, we can sketch them out again. My min is at 3 and negative 22. My inflection point is at 2 and negative 11. Probably should put that a bit lower. And my stationary point inflection point is at 0.5. Okay, so if I'm drawing this out, the first thing I'm going to draw is my min, because that's the easiest. You know, this is an inflection point, so it's going to change direction over here. This is a stationary point and an inflection point, which means the graph becomes completely flat there. And then since it's not a maximum, it's going to be going upwards.